All right, now let's perform the same qualitative analysis to the following differential equation, just so you can see that in practice it's much quicker. So let's first find, as usual, the equilibrium points or equilibrium solutions. So all this means is set the right side equals 0. So y prime equals 0, which implies y plus 2 times y minus 1 squared times y minus 3 equals 0, which basically gives us three solutions. Y is minus 2, or y is 1, or y is 3. So three of them. And now let's draw the bifurcation diagram. Bifurcation diagram. Meaning, once again, that's a table with signs. So what you do is you put y and all the components. So y plus 2, y minus 1 squared, y minus 3. And then the derivative, which in this case is a product of all three things, by the differential equation and a function. That's one thing. And then minus infinity, all the equilibrium solutions. So minus 2, 1, 3, and infinity. And now is where the fun starts, where we put all the minuses and pluses. So y plus 2, it's minus, and it switches signs. So here it's 0, and then plus, plus, plus. For y minus 1 squared, trick question. Well, remember, it's always positive. So plus, plus, 0, plus, plus. And a very positive behavior. And in y minus 3, I believe it's minus, 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 0 plus. And then y prime is a product of all things. So I believe it becomes plus 0, and then minus, and then 0. And I think another minus, 0, and then plus. Should be like this. Okay. And then all we'll do is remember, whenever the derivative is positive, the function is increasing. When it's negative, the function is decreasing. So it becomes increasing, decreasing, decreasing, increasing. It's one thing. And then we can draw the graph, because that will help us classify the solutions. Maybe let me do it here, just for visibility. So we have this minus 2. We have the solution 1. And we have the solution 3. And then let's see what happens. Well, if we're below minus 2, the function goes up. So it probably looks like something like that. So it has to curve up this way. And then between minus 2 and 1, the function goes down. So it just curves down like that. And then between 1 and 3, it also curves down. And then above 3, it curves up. Very good. And now, last but not least, so I did it in one question before, but we can also split it in two questions. Let's classify the equilibrium solutions. Equilibrium solutions. By the way, on an exam, I would tell you those 3 steps. I wouldn't just tell you do a qualitative study. Okay, now let's see what happens. Well, what about -2? It looks like solutions are going towards -2. So y equals -2 is stable. Well, 3 is unstable because solutions go away from it. Unstable. And then for y equals 1, there's a peculiar situation because notice below 1, solutions move away from it. Above 1, solutions move towards it. So because it kind of swings both ways, we call it bistable. So it's bistable. And all this means is stable on one side, unstable on the other side. One side, unstable on the other. And that's it. Those are the 3 steps you need to know to do a qualitative study of an ODE, which again is a way of getting info out of it without actually solving it.